Weekly from Business School of AI. Weekly is our happy place to share, learn, discuss, and explore. Weekly occurs every Wednesday at 9 a.m. Pacific time. I'm your host, Yashaswani Viswanath, and you can call me Yash. I'm logging from Bangalore, India, and I would like to know where you're all coming from. Please type away your name and location in the chat. We would like to get to know you better. I am an AI researcher who focuses on responsible AI, and at Weekly we empower and enable the students to break into AI and to explore more of it. Generally, we host speakers from varied backgrounds working on AI and allied technologies. Today is a very special session as I am going to teach about what is explainable AI. So I'll be explaining explainable AI. This is a special session of a webinar format, and we will be recording this session. So if you want to go off camera, please go off camera. And this is live streamed on LinkedIn, Twitter, and YouTube. So welcome everybody for the session. And I'll be sharing my screen now. So are you able to see the screen?
Yes.
Welcome again to Weekly and welcome to this session of Explaining Explainable AI. So if you see this image, you see an AI that is trying to explain something to the audience here. So let us go over. When we look at the AI space, it has started somewhere around 1950s. We had artificial intelligence started from the Turing tests and imagination of how an AI can be. And then in the 1980s, we saw the machine learning wave, and the 2010s, we saw the deep learning wave. So we have the super AI, the general AI, and the narrow AI. The narrow AI does something very specifically, and the general AI, something like the foundation models that Stanford has put forth. It will be able to do a varied kind of tasks. And here, when we come to explainable AI, I would like to give you an example of a recommender system that you see in Netflix. Whenever you go over Netflix and see the recommendation system, you have the varied movie recommendations that you get there. Have you ever wondered why is it recommending to you? Why is this particular recommendation coming for you? Here is one more example. Sam applies for a mortgage. Sam's application is imputed into an AI. AI estimates Sam's probability of defaulting. Sam's mortgage application is rejected. This is a very simple example of an AI use case where an AI model decides which mortgages to approve. So here, Sam's mortgage application is rejected. And the question comes, why was it rejected? Who will ask this question? Will the bank ask this question? Will Sam ask this question? Will others who want to apply for the same loan ask this question? Will the regulatory body ask this question? And here is one more example of creditworthiness. So generally, when there is a loan application, the AI model decides who is creditworthy. And here, if you see, there are varied features, and which feature actually impacts the creditworthiness is seen by the thickness of the line. And we see various features such as the number of children, the credit score, whether they're employed or unemployed, the income group, the term length, the previous loan count, and other macro effects such as the inflation rate, the unemployment rate, and GDP growth. This is a small peek view that I gave about explainable AI. And here the question arises, why do we need explainable AI? We see AI in transportation, in finance, in security, in legal, in medicine, in military. And when we talk about explainable AI, the users ask questions such as, why did you do that? AI, why did you do that? AI, why not something else? AI, when do you succeed? AI, when do you fail? AI, when can I trust you? AI, how do I correct an error? So now let's dwell deeper into what is explainable AI. So we think about responsible AI in the broader sense. It has explainable AI, interpretable machine learning, secure AI, ethical AI, compliance, human-centered machine learning. In the previous weekly web sessions, we have understood what is responsible AI. We have had many sessions on AI ethics by Susanna, by Sudha, and Renee. We have understood the various facets of responsible AI, and explainable AI is also one of the legs of responsible AI. Here comes the question, is your AI ethical, transparent, compliant? Is a question that others are asking, is a question that we are asking, is a question that everybody is asking. When we talk about GDPR, we talk about fairness, privacy, transparency, and yes, we do talk about explainability when we talk about the implementation of the GDPR laws. Explainable AI can be considered the collection of processes that help the developer and the users understand and interpret the results of the AI. So generally, the questions are how data sources and results are used, how the input for the model leads to the output, the strengths and weaknesses of the model, the specific criteria that the model uses to make the decision. This is very, very, very important. What is the criteria that the AI is using? Why a certain decision was made? And which alternative decisions it could have made? To which type of errors the model is sensitive and how to correct these errors. So here we see a simple representation of what an explainable AI is. So generally we have the regular black box artificial intelligence, and it says, yes, say this is an example of credit approval process. It just says yes or no. Can we give them the credit? Can we not give them the credit? When it's a black box, it just says yes or no. But when we have a transparent explainable AI, it says no because the age was lesser than 25. No, because the salary was lesser than $1,000. No, there were more than 4 unpaid bills. It says why. Why did I reject the loan? This was the reason. And then we see here, we have the AI model and the input data that we give to it. How are we making the change to bring in explainable AI? We have the explanation interface and the explainable model. So we ask the question, why did the algorithm do that? Can I trust these results? How can I correct an error? So when we have the explainable AI in terms of the explanation interface and the explainable model, the domain expert can understand why, the domain expert can learn and correct errors, and can reenact on demand. When we think about a machine learning system, one of the fundamental and a very simple machine learning system that we talk about is image classification, where we give cats and dogs. We give a bunch of cat images, we give a bunch of dog images, and we ask the machine to learn what is a cat, what is a dog, and then we give an image and ask the machine to tell us whether it's a cat or a dog. So generally, we have seen this in the teachable machine demos in our class, and we call this the classification model. It's the fundamental model that is there in AI. And here, AI generally just says this is a cat. But if we want to bring in explainable AI, the AI will reason with the user, telling it has fur, whiskers, claws, it has this particular feature, and it provides an explanation along with the classification. So today, when we think about explainable AI, the explainable model and the explainable interface, the user will be able to understand why this decision, why not this category, why wasn't the loan approved, when will the AI succeed, when will the AI fail. And even in terms of the loan application, if we see who are succeeding, who are getting the loans, who are not getting the loans, when to trust the AI, and when will the AI make mistakes. So if we see here, we have the earlier model where we just had the learn function and we saw the output. Now we have the explainable model, which has a new learning process, and it gives us an explainable interface, which helps the user with the task. Here, if you see, it's not just the cats and dog example, it can be anything. If we have to consider, here there is a car, there is a neural network here that we see, a CNN model, a convolution neural network. And in the explainable stage, it is telling it has wheels, lights, and these are the visual features obtained from the model. Earlier, it used to say it's a car with a confidence of 0.89. And now we can ask, why is this a car? Why did you classify it? So if we see the large amount of training data that has gone into the classification model. So we saw the cats and dog examples. This can be a car, no car classification model. Now, what are the challenges that we see here? When we think about the explainable models, we need to develop a range of new modified machine learning techniques to produce more explainable models. And the interface that we are having, it needs to integrate with state-of-the-art human-computer interface with new principles, strategies, and techniques to generate effective explanations. And what about the psychology of explanation? Do we summarize? Do we extend? Do we apply current psychological theories of explanation to develop a computational theory? Explainable AI is for different reasons. We explain to justify, we explain to control, explain to discover, explain to improve. The AI needs to explain for us to be able to understand what it is doing, why it is doing. So the AI should explain and justify. It has to explain for control, and it has to explain so that we can bring in improvements into the AI, and explain to discover. Here we see a very nice example of BMI. So when we talk about BMI, we have the different features which go into the to determine whether a person is on the higher scale of the BMI or not. So here, if you see, we have different features like age, BMI, blood pressure, and the gender. And we look at what are the features that are making a difference to this. What is it affecting? Here we are looking at the mortality risk score. In the earlier black box model, we just got a score, but now we get how much did age matter? How much did the blood pressure matter? How much did the BMI matter? How much did the gender matter? Here we see the various explanations, the amount of effect that it is having. And here, this plays a very important role in knowing what features impacted. We have, if you see here the word SHAP, It's the shapely values that we use for local explanations. It's one of the important softwares that we use to drive in explanations. So now when we have explainable AI, we can reduce the impact of model biasing. We can bring in responsibility and accountability. We can improve governance. Code confidence can be improved and code compliance can be improved. So how do we do that? Reducing costs of mistakes. So when we have decision sensitive fields such as medicine, finance, legal, they are the areas which are impacted by wrong predictions. So here, when we look at these areas, we can know what is the root cause and we can improve the model, underlying model. And when we have the impact of model bias, we can look at the gender bias, the racial bias. An explainable system can reduce the impact by explaining the decision-making criteria, and thus we can reduce the biases. And when we look at the responsibility and accountability, we can enable a person who can be responsible and accountable for those errors, and we can make the overall system more efficient. And when we think about the code confidence and the code compliance, we have the regulatory bodies which have multitude of rules which we can follow by using explainable AI, and we can comply with such regulatory bodies. So now when we think about the different applications of AI, we can look at customer retention, claims management, insurance pricing, fraud detection, payments exceptions, collections, robot advisors, banking customer engagement, AI-assisted drug design, AI-integrated healthcare conditions prediction. These are various fields in which AI can play a very important role, and we can bring in explainable AI. We will see some of the examples. So for example, customer retention. One of the cost-effective ways to retain customers and to acquire new ones is to look at the churn data. Who is churning? Why are they churning? This will lead to the question, what can we do about it? Claims management. When we have insurance and such, claims management plays a very important role where we can give a reason for claim approval or disapproval. Insurance pricing, banking, healthcare. In the healthcare sector, we have the cancer, no cancer, diabetes, no diabetes, such classification models which will enable the doctors and assist them to detect a few diseases that are there. And we have other fields such as drug design also. So what are the 5 key questions that we need to answer when building explainable AI? Explain to whom? There are different stakeholders that come into picture when an AI is working. Here, all the stakeholders are important, and we should not be leaving out any of the stakeholders. And we need to develop explainable AI methods which consider everybody. Why explain? So here we need to list the objectives and reasons for explanations. How do we explain? We need to explore the different methods of explanation. When do we explain? Understand the need for explanation. Do we need the explanation before, during, or after the model is built? And what are the techniques? What are the techniques for explanations? First, let us look at whom to explain. End users. These are consumers who are receiving an explanation on a decision. We saw the loan approval, so that is where the person who applied for the loan comes into picture. When you're using a Netflix recommender system, you're the consumer, you are using the recommendation system. When you're on Amazon and trying to buy something, you're the consumer there. The explanation itself might be delivered digitally or through a human. So generally when we see recommender systems like Netflix, we get, you got this recommendation because you saw this movie. And when we go to Amazon, we get an explanation telling you purchased this and that's why you were recommended this. So generally in a bank, there could be a loan officer who will give the explanation. Business sponsors, they're the executives of business and they need to know why the AI is taking these decisions. And the business sponsors are concerned to know more about the model interpretability. The primary concern of business executives is the governance process, so that the organization is compliant with the regulations and customers are satisfied with the explanations. Data scientists. Yes, data scientists are the ones who design, train, test, and deploy and monitor the decisions, actions, and the recommendations made by the AI systems. So here, the explanations can enable them to debug the system, to check where are the errors. And this can enable them to enhance the model. And then they can also see if the explanation is actually reflecting the reasoning of the model. Is it applying for the regulatory requirements and the user acceptance? Regulators. So we have the regulators who want to ensure that the AI system does not discriminate or harm any individual or a group of individuals. Depending on both the sector where the AI system is being used and the nature of the AI application, the rigor required for the explanations may vary. Different scenarios require different types of explanation. So the regulators would like to know that everybody is given adequate explanations. Now let us see about the different explanation techniques. Feature relevance. Here we are looking at the inner functioning of the model and looking at which are the features that explain the outcome of the model. Model simplification. Now, if we look at the models, if they're the black box models, the common question is, how is this black box model giving this explanation? We can build a new model that is the simplification of the more complex model that is to be explained. Local explanations. We can look at the space, the solution space, and provide explanation for smaller segments that are less complex. This is very important, explanation by example. So here we extract specific representative data to explain the overall behavior of the model. Visualization. This is one of the explanation techniques where we visualize the model behavior and thus we reduce the complexity of the problem. Textual explanations. So this is a very happening and hot area of research. So by the usage of natural language processing, the natural language generation, we are trying to bring in explanation into the natural language text. How do we, this is dwelling deeper into the explanation techniques, how to explain an ML model post hoc. We have the local explanation, global explanation. Do we take the individual prediction? Here we come across terms such as model specific and model agnostic. So model specific is an explanation technique where we are using the innards of the model to generate explanations related to that particular model. Whereas model agnostic is the technique which it does not depend on what model we are trying to explain. So model specific, we have the integrated gradients, the tree feature contribution. And for the model agnostic, we have Lime and SHAP. When we look at global explanations, we have tree gain based for model specific, and for model agnostic, we have partial dependence plot and permutation importance. So here we are trying to think about whom. We're trying to think about the stakeholders, the targeted audience. If you look at the domain expert, the users of the model, like the medical doctors and the insurance agents, why do they need explanations? Because they need to trust the model. They need to get the scientific knowledge. Users who are affected by the model decisions, they need explanations. Why do they need explanations? They need explanation to understand the situation and verify whether the decisions are fair or not. The stakeholders of regulatory entities and agencies. Why do they need explainable AI? They need to certify model compliance with the legislation in force and audits. We looked at data scientists, developers, product owners. Why do they need explanation? To ensure and improve product efficiency, research, and new functionalities. What about the managers and executive board members? Why do they need explainable AI? They need it to assess regulatory compliance, understand corporate AI explanations. When we think about explainable AI, we saw the various stakeholders. And here is an example from the Department of Defense. Here they look at the different stakeholders such as the commander, the policymaker, and the end users in the Department of Defense, and the developers, the AI experts, and the task subject matter experts. They see who are the different stakeholders and why they need explanations to carry out their task, their job. So the developers need explanations so that it can explain the final details of the system, so that they can modify or refine the system. The end users will need explanation to aid them in decision-making or recommendations, to justify the actions and decisions. The policymakers and the regulators, they need the decision patterns. Are they defensible? Do the decisions meet policy regulatory requirements? So we say a good explanation incorporates context about the user's knowledge, task, concept of operations. Here we see the requirements of explainable AI. When we talk about the decisions that the AI makes, some of those decisions are critical, some are not, some are irrevocable, some are personalized, some are routine decisions, some are experiential decisions. And here we see the extent to which explainability is required. Let us take a few examples here. Let us take the example of a smart home system. How critical it is. It's a routine decision that is taken. Now, if we see automated diagnosis, it's an irrevocable decision. Crime prediction, autonomous cars. The criticality of the decision is high, and the extent of explainability required is also high. What about marketing recommendation engine? The criticality of the decision is high, whereas the extent is not of that importance. It's somewhere in the middle. It's a more personalized explanation. So this gives us a very important point where our applications that we are building, that we are dealing with, we can think, are the decisions critical? And to what extent do we need the explainability? So we saw that explainable AI is a two-stage problem. So first is we need to see what is happening, and then we need to map it to the mental model of the consumer and communicate it effectively. This is really important because the user needs to understand the explanation. Here, when we look at the detection and prevention of fraud, earlier the machine just used to provide a risk score, and now it provides an explanation. So this enables the analyst to make a decision based on the explanation and score. So the analyst here should be able to understand the explanation. Generation of the explanation is one part. Understanding, representing it in a particular manner to enable the understanding is a two-stage problem. How do we bring in explainability into the AI workflow? Here, if you look at the entire life cycle, we start from the training, where the explainable AI enables model debugging, model visualization. Then we have the quality, where we have the model evaluation and compliance testing. The deployment, where the model is signed off and the model release management kicks off. Then we have the prediction. We need to provide explainable decision and provide API support. At the juncture of A/B testing, we look at the model comparison and cohort analysis. And when we look at monitoring, we need to have the performance monitoring and the fairness monitoring, debugging, root cause analytics of why decisions were taken, model diagnostics, and it's a feedback. So this was taken from Fiddler AI. And when we talk about explaining black box AI, here we are looking at the banking application use case. Lack of insight into why and how customers churn. This is in the churn related use case, and more in how to fix the churn is the question here. Yes, the churn is happening. How do we fix it? Explanations help with that. And then we see who are the ones who are having loyalty, who are at high risk, who are at low risk, and how is the revenue faring? How are we faring with respect to the competition? And churn helps us to detect this beforehand so that we need not suffer. There are many use cases in the financial sector, such as risk mitigation, to understand the decisions and allocate resources to minimize financial risk and maximize return, anti-money laundering, customer retention, fraud detection, investment decision making, and credit scoring. These are the various uses of explainable AI in the AI domain in financial services. Then we can look at building customer trust, reducing costs, and staying compliant. This is in the fraud management sector. Then we look at explainable data, explainable predictions, explainable algorithms. These are the three main important parts of explainable AI. What was the data that was used to train the model? What features and weights were used? What are the individual layers that were used for the prediction? These questions around AI explainability help us understand how data, predictions, and algorithms influence decisions. Here is a brief summary of what we saw. We saw about the different types of explainable AI. And then if we look at the different kinds of models that we have interpretable models, the ones that are easy to interpret for ones that are difficult to interpret. So let us go over this algorithm. Explaining a model's decisions, yes. Is the model interpretable by design? Then if we look at logistic, KNN, linear models, which are interpretable for uh, by design, or do we need a method that works on all models? So we look at the model specific techniques such as gradient saliency, integrated gradients, attention, or we go for model agnostic techniques such as SHAP, LIME, perturbation. Explaining a model's decision by different neural representations if we are not going to explore the model and its internals. Now, this is from IBM Explainability 360. So are we trying to understand the data? If we are trying to understand the data, then the samples and the features are looked at. Case-based reasoning using prototypes and criticisms for the samples. And for the features, we see which were the meaningful features. If you see here, we have the various stakeholders. We have the data scientist, the decision maker, the regulator, the affected user. Who is interested in what? Who is interested in the data? The data scientist and the decision maker. Who is interested in the local explanation? The affected user. They want to know about which are the features. What are the samples? When we look at the global explanations, the post hoc explanations and directly interpretable models, we look at the decision maker, the regulator, and the data scientist. So here, the key takeaway from this slide is different stakeholders are interested in different parts, different segments, different iterations of the explanations. This is a huge slide. So AI is a lot more than classification. AI is a lot more than prediction. So we have AI in planning, we have AI in search, game theory, robotics, natural language processing, uncertainty quantification. Here we see the complete ecosystem of AI and how explainable AI can matter in each of these. We can go into each of these type of AI and dwell deeper into explainable AI implications in each of these types. Now, when we look at the applications, the different market segments, we've talked about drug discovery, fraud detection, supply chain management, recommendation engines, access management, social media advertising, predictive maintenance. These are the various market segments. When we talk about the models, this is a very beautiful graph, and this is foundational because as the complexity of the explainable of the model increases, the explainability reduces. So if we see the accuracy of classification decision trees is lesser, but the explainability is easier. Whereas neural networks, the accuracy is higher, but the explainability is tougher. Now, when we look at this extension of the previous graph, we see how the prediction accuracy and explainability are related to each other. We see different types such as ensemble models, random forests, decision trees. Where do they fare in terms of explainability? What about statistical models such as SVMs, graphical models such as Bayesian belief nets, Markov models? This tries to cover various models and how it fares on the explainability chart. What about deep explanations? How do we modify deep learning techniques to learn explainable features? Interpretable models, techniques to learn more structured, interpretable causal models. Model induction, techniques to infer an explainable model from any model as a black box. So these are various techniques that are out there. This is an extension of the previous graph. This tells about the models and their explainability. Here we see rule-based models, linear models. We move to the graphical models, the statistical models, the ensembles, the deep learning models. We see the RNN, CNN and RNN here. We see how they fare, how is the performance and how is the explainability. Here we saw about the training data. We give it to the learning process. We get a learn model. We get the predicted output. Here we create something called an explainable surrogate, which will enable us to know whether it is transparent and trustworthy. We will get the answers for our questions, such as which features determine the prediction, how can I trust this prediction, how can I quantify the uncertainty. Here, if we see, we have the data sources, the machine learning models, the explainable artificial intelligence. It consists of the model, the explanation, and the visualization plays a very crucial role. How do we convey the explanation to the user? That is what we saw as the two-stage problem that time. And the human evaluation, how the users evaluate this. This is a summary of the entire talk that we had today. We talked about the need for explainable AI. We looked at the challenges. We understood what is explainable AI, why we need it, and we looked at the different use cases. So this is the end of my slides, and I'm open to questions now about explainable AI.
Yes, this is so great, actually. Very, very excited to, get my hands on trying out some of the model explainability. So I'm curious, can you hear me, right?
Yes, yes. I can hear you.
So I was actually very much excited to see if I can try a classification model, and then, what tools do I need to add to that to see if it's predicting a dog or a cat? Because I think that is one of the nice examples that you shared.
Yes.
So
So what I can do is we still have 10 minutes. So I can show a brief demo of IBM Explainability 360. It has a demo in that, and I will just show that so that we can look at a classification model in that. But it is not an image classification model. It's a loan application related
Sure.
example.
Yash, I have a question. Since you said visualization plays a very important point, and there are multiple stakeholders who have an interest in learning the explainable aspect of an algorithm, is there different explainable AI techniques or framework that works for compliance people or finance people, different from the engineers, different from customer support? Or is there conflict between them when they look at the visualization? Usually when you present data, there is conflict on agreeing on what the insights are, though statistically there are certain insights. So do you see that in explainable AI?
From whatever survey I have done of the latest tools that are there in this area, currently the visualizations cater to the data scientists level, where they can understand. The main research area that is going on in this field is related to the natural language explanations. How do we tell to the users about this explanation? This is an area that needs a lot of work. So whatever challenge you mentioned is one of the research problems that is there in the future work in terms of explainable AI.
Thank you.
I will share my screen to show the Explainable AI from IBM IBM Explainability 360. So just let me know if you're able to see this. Here there is we have the credit scoring company, and we have the credit score data set that's related to that. They tell us, so Sudha, answering your question, here there is a demo on how do we show the explanations to different people. It is not just showing the explanation, it is even the content of the explanation and what exactly they are trying to ask. So let us see that here. So we see that a data scientist will try to ensure that the model works appropriately. A loan officer in this credit scoring, credit loan approval scenario, he needs to assess the model's prediction and make the final judgment. A customer wants to know the reason for why the application was rejected or accepted. So let us go to the customer first. So here also we see different people need different explanations. So a customer needs to know why my application was rejected. How can I improve the likelihood of my application? Here, if we see, there are 3 customers in this demo. We can go to Anne. And so Anne's recent credit inquiry suggests she's a high-risk candidate. If the most recent inquiry was more than a month ago, her application would fall in the approved category. So we see that her recent credit inquiry was not within the last 7 days. So it needs to be around 2 for the application to be approved. We can go to Jason and see the different factors which are contributing to the application. And now we can go back and look at the data scientist perspective. Or before that, we will go to the loan officer. So the loan officer, we see 2 things, the approved and the denied. We'll go to the approved category. Here, it gives which feature contributed to what. Why was Alice loan approved? It gives an explanation. It tells which feature affected for the loan approval. And when we go to Robert, who was denied, it also gives why was it denied? Who are the other customers who are similar to Robert and what has happened? If we go back and look at the data scientist, so we see that the kind of explanation given to them is more related to the risk estimate and what the model is giving as an output. So Sudha, here the question is, each person is interested in a different thing. If we see here, a user will be more interested to know why the loan application was approved or rejected rather than how the model is doing a particular thing. So this is AI Explainability 360 demo that I wanted to show. And I'm open to any other questions that are there. But I think we are nearing the end of the session. And any other questions?
This is very good, Yash. Especially for the same system. That's what I had thought, that it all are algorithms for explainable AI. So it's still with the data scientists. And having something like this that different stakeholders can see is a good starting point for them to have a conversation. So finally, somebody who's a product manager building it might want to create an interface so that the customer can see why their loan was rejected. And finance might say, hey, this is going to create risk for us. And then go ask an explanation to the data scientists, and they can remove bias from the model and keep improving it. So this is actually very good. Thank you.
Thank you, Sudha. And yeah, I think we are nearing the end of the session.
Yes, sorry to interrupt. You had something that you were going to give a digest to people who are interested in the topic as follow-up.
Yes, just a second.
You're doing this 100 days, right? Every day you're posting a explainable AI tip.
I'll share my screen. Yes. So I'm running this 100 days of explainable AI on LinkedIn. And so this is the landing page. You can subscribe to this digest. So every time I move over 7 days, I send it over as a digest. So every day I put it up on LinkedIn. And if you subscribe here, so on the 7th day, the 7th, 14th, 21st days, you get it as a digest of that 7 days and into your mail. So I'm posting all about explainable AI, starting from the scratch to an extent where research papers can be read and research can be done. And I have borrowed this word from Susanna, the lived experiences, and I strongly believe in that. And so we can bring in our lived experiences into the explainable AI domain. No borders, no limits. You can be anywhere in the world and you can subscribe to this digest. And this will enable you to get further updates about explainable AI. And there's 100 days of AI that I'm doing. It will take from a novice to an expert totally.
Thank you, Yash. I'm sharing that.
Also, Sudha, I just want to share about Pradipta Mishra's book, who is my teacher. So if anybody who is listening to this session and wants to read Explainable AI in a book format, and so here is the link for the book, one of the first books that I read about Explainable AI. And Professor Pradipta Mishra is the author of this book, and it's Practical Explainable AI. And I've shared the link also here in case somebody would like to read it in a book format. Apart from this, I share a lot of tutorials, a lot of PDFs, videos in the 100 days of explainable AI. So that itself covers all the concepts, and following that will take you deeper and deeper into explainable AI. So I think we should close the session. We have reached the end of the session.
Thank you, Yash. Thank you. This is very good. We'll follow you on your 100 days, and then I signed up already, so I'll get the weekly digest from you.
Thank you, Siddha. Thank you, everybody, for joining this session. And we will meet next weekly vet, next Wednesday at 9 a.m. Pacific time. We have Dr. Usha Jagannathan, who will be talking to us about life of a researcher, and looking forward to talk to everybody next Wednesday. Thank you.
Thank you. Bye. Bye,
Bye.
everybody.